All right, that's enough about cookies. Okay, so let's talk about who our presenters are and what are their topics. So we've got 6 2-credit hour students and 6 posters. Coincidentally, we're going to number these off by breakout room. Room number 1, Kandarb Shah has created a class, a mechanical engineering class. He numbers as 408, Production Technology. And I apologize, it looks like I decided to make his title italicized, likewise with number 6. But anyway, please ignore the inconsistency. Avant Meta has proposed a similar course, ME 395, Introduction to Machine Shop Tools. So I think I would suggest that if you attend one of either of those, don't attend the other one in mechanical engineering. Okay, go try to diversify some of the different sessions that you attend.
Hello, Waging, are you with me?
Yes.
Awesome. So the way I'm going to go about my poster is I'm not going to advertise it per se, but I'm going to go through a technical aspect of why I designed it a particular way. So first up, in the very middle, I have a picture. I know pictures are what people like to see on posters, so they get the gist of it really fast. Do you want to machine this part? Take ME395. Now, when the audience sees that, immediately I want them to think, if they want to machine a sample part like that, they should take ME395. But what is ME395? It's a hands-on class where you learn to use a variety of machine shop tools. There's 3 focuses over here: using them efficiently. So I want the students to learn how to use them fairly quick without spending too much time thinking about how to use the tool, but more so on their design and manufacturing aspect. I want them to use it confidently and safely, and that goes hand in hand because I don't want them to lose fingers while working on the table saw or get injured while using the bandsaw, the hacksaw, etc. My class has no lectures and there's no competitions. When I was an undergraduate, the class where we learned about machine shop tools had a competition where we built robots, but here it's a 2-credit class. There's no lectures, no competitions. It's a hands-on focus. So in this class, as you can see in the weekly schedule, there'll be a different focus for which tool to use every time. We start off with safety protocols because that's the first and foremost thing I want the students to learn, so they don't get injured and they know how to adhere to the safety protocols. Then we have vernier calipers, mass balance, and that's going to be introduction to metrology and measurements. Then we have the cutting type of tools, bandsaw, hacksaw, and quick deburring. And in a similar fashion, there's all sorts of different machine shop tools. The main focuses are the mill, which is in 5 and 6, and the lathe, which is in 8 and 9. Now, there's also in-class assignments, as you can see in the grading here, that there's 8 different lectures where there's going to be, sorry, not lectures, but classes where there's going to be in-class assignments. That's 2, 3, 4, 6, 9, 10, 11, and 12, and that cumulatively adds up to 80% of the grade. The remaining 20% is the final project. And actually, that was the first thing I thought of when I thought about designing this class and how I can incorporate a unique idea that's not been seen before into the curriculum through the machine shop tools. And that is that in the first week of 2 of the final, the TAs will give the students a part that the TAs already made beforehand to the students. And the students will measure the dimensions of the part. They'll make their own engineering drawings for it. And they'll make sure to, first of all, take down the entire geometry as appropriate. They won't over-dimension when they're measuring the different features of the part given to them. At the same time, they should take enough measurements to fully dimension the part that they're going to be manufacturing in the second week of the final project. That's week 14. Where over there, they're simply going to create their own replica of the part they were given in the first working week of the project. But the thing is that they can only use their drawings which they had from week 13 and not have the same part which was given to them back in week 14. The grading, as you can expect for the final project, is based on the measuring and manufacturing accuracies. That is to say, how close were the measurements to the part given to them, as well as how close was the manufactured part to their drawings. And then we have adherence to safety protocols, which basically means, especially for week 14, have they worn their safety glasses? Have they not put their fingers in dangerous places so their fingers might get cut off, etc.? and they'll have a part that looks similar to this. So what are the motivations to take ME395? There's two main reasons. First up, if you're a transfer student and you didn't learn how to use machine shop tools at your previous institution, you can take ME395. And again, because there's no lectures or competitions, you don't have to learn the things that you learned in your design class, or you don't have to learn about geometric dimensioning and tolerancing again, because that's something, as you can see in the prerequisites, you should have known from before. Heading into this class, you just focus on the machine shop tools. And secondly, if you want even more exposure to machine shop tools, for example, if you've done mill and lathe before, but you want to learn the other things in the class, which are more unique, and to broaden the scope of the class a little bit, you can take the class and you will gain the exposure to all of those. Then we have the fine print. For the prerequisites, you should have knowledge of GD&T or take ME270 from before. There's a meeting time. The grading, as I said, is 20% for the final project. And the in-class assignments, there's 8 of them, and they're each worth 10%. And the 8 of them occur in the weeks with stars. And there's also a textbook for additional learning, but that's not really required per se for the class. But again, it's for additional learning if you want to learn about specifics of the machine itself, or more details, you can say. So with that being said, I would like to open up the floor for questions that you guys have.
I guess I have a quick question. So, so since there's no lectures, right, and the meeting times look like they're like 3 hours, like what would you expect, like the because I would assume you teach how to use the tools during that time. Like, would it be like an hour or half an hour of like explanation before they start hacking away at stuff, or like how would you imagine that?
So the way I imagine this is that each of these weeks have different lengths for the amount of work they're going to do. Like, for example, the safety protocols lecture, although it is important, of course, is not one that's going to take 2 hours. I mean, for example, the create sample part on the mill is going to take maybe up to 3 hours, depending on how well the students understood the content and learning how to use the tool there. But again, I didn't say they're lectures, because although there are explanations, of course, like learning how to be safe, learning how to use the specific machine shop tool, it's not like you're going to just look at the presenter speaking for like an hour. That's not like that. You have to learn by seeing and by using your hands. So it's not a lecture in that sense.
Gotcha. Okay.
One thing that I want to note, which I didn't earlier, is talk a little bit about the learning objectives. So I took module 5, which is both the milling lessons, as an example. And actually, I incorporated what we learned from Bloom's taxonomy into making the sample learning objectives here. So just look at the keywords I used. So to recall actually refers to knowledge. To analyze is directly one of the things from Bloom's taxonomy. And to create, I want to show you that because I was pretty happy to see. Whoops, where am I? I was pretty happy to see that creating is on the very top of Bloom's taxonomy over here. And that makes a lot of sense because the way humans understand things, the very best is when they have their hands on it and they're actually creating something, as opposed to just looking at text on a screen or something, or a lecturer. Like, that's at the very lowest end of the pyramid, but creating on their hands, what helps them understand it the best. So I was also happy I could incorporate Bloom's taxonomy into this. Alrighty, do we have more questions? Thank you, Hamming. I appreciate it. If you have any questions, please let me know. Blake is not here. I thought he was. Man. Okay, I have 30 seconds. So, thank you guys for coming to my presentation. Hope you enjoyed.
Thank you.
Cheers.